Hi, and welcome to my first ever YouTube video. I've been wanting to make videos like this for a while now, but never quite got around to it because I never really had the right equipment. Finally decided to sort of just do it and half-ass it, so otherwise I'd just never get to it. So I hereby welcome you to my shitty half-assed video. And in this janky video, I will be working on an oscillator that is going to be part, hopefully, of a synthesizer of the modular variety that I'm hoping to eventually build someday. I have a lot of projects and most of them never finish, so this might be one of them. But hopefully, making these videos will be motivation to actually finish a thing. So, alright, so let me get to the bench behind me there and let's get to it. You've got this little circuit here, your typical multi-vibrator circuit that you see in every textbook. Here it is on the breadboard. So what we've got going on here is that multi-vibrator circuit, and you can see here I added some very high value, well, very high. They are 470 microfarads, so fairly, high value capacitors, so that it would be slow enough so that we can visualize what's going on here with these here LEDs. So, each LED represents a part of the circuit. The supply voltage is coming from their shitty power supply, coming into the right hand side here through this wire, which is why this LED is always sort of brighter, because that's where the whole thing gets initiated. It's hooked onto VCC, so when this transistor switches, you only sort of see it dim a little bit. Whereas this one, you can actually obviously see the switching of on and off because it doesn't have the supply voltage always there. Anyway, so you can sort of see that, these sort of go back and forth. And then here is the output LED on the right hand side, where you can see the actual pulse that is the result of the difference of these two, basically. All right, so on the scope here, let's see if I can rearrange my stuff so that you can see both the circuit and the scope. Hopefully I don't break anything. So we can see here in yellow the waveform that is the output, and in the other channel, the blue, is the supply voltage of the control supplied by this here 9-volt battery, which then goes into this here potentiometer so we can adjust it, which should, in theory, change the frequency of the oscillator. So we can see here, there we go, frequency is about 1 Hertz. Alright, so let's change capacitors. Since the whole point of this thing is to build an oscillator for a synthesizer, we're going to want a higher value capacitor so that we can actually hear something and hook this thing up to a speaker. So let me quick change the capacitors here, and then we'll see what sounds we can make with this. So, alright, changing capacitors. Just gonna turn the power off here for a second. There we go. And pull these guys out. And let's replace them with, how about these guys? Let's, what are you? 10 microfarad. It sounds like a nice round number. Shove that in there. Yeah, this is ghetto style, not like making it all look pretty and stuff. And this guy goes there. Hopefully it's in. We'll find out. Hey, more lines. Alright, so now we've got some actual, hopefully audible stuff. So let's change this here to something more reasonable. Actually, I should be able to auto trigger now, or auto configure. Hey, there we go. And then to our other channel. Alright, so, and then let's make it a little bigger. Change this to about the middle. Yep. Alright. Cool. So still yellow is output, blue is control voltage, and it's the same thing when I higher control voltage, lower control voltage. So you can see the frequency goes down as the voltage drops and goes up as the voltage increases. Okay, so what does this actually sound like? I've got this whole thing hooked up to that there guitar amp over there. So let's find out. Hopefully. Alright. Alright, there we go. It makes racket. Success, somewhat. The end.